After more than 50 years, humanity is returning to deep space. This 32-story monument to thrust is currently the only bridge back to the moon. This massive engineering project eventually narrows down to these four faces. These are the specific people who will occupy the tiny pressurized volume at the top of the stack. The physics are unforgiving. We are taking fragile biological organisms and strapping them to a massive explosive device. Notice the entire SLS structure is massive, holding millions of pounds of propellant. All this energy just lifts that small capsule. To reach the moon, it must hit orbital escape velocity, accelerating over 24,000 miles per hour to break Earth's gravity. Leaving the planet is a brutal contest against inertia. Deep space exploration requires surviving the precise, cataclysmic application of force needed to punch through the sky. At T-10 seconds, the core RS-25 engines ignite. They instantly begin converting liquid fuel into a violent, expanding plume of white-hot exhaust. These white segments make up the twin solid rocket boosters. They provide the massive initial thrust needed to move millions of pounds of metal against the weight of the atmosphere. The ignition generates staggering acoustic energy. These sound waves act as a physical, destructive force, violently vibrating the launch pad's steel until it sheds debris. Once booster ignition occurs, the chemical reaction is irreversible. The crew is committed to the ascent. Achieving this level of thrust requires pushing every material and weld to the edge of failure. The crew inside is about to endure the extreme physical consequences of that engineering. Liftoff. The vehicle transitions instantly from static weight to intense vertical acceleration. As the rocket punches through the densest part of the atmosphere, G-forces press the astronauts back into their seats with several times their own body weight. Outside, the spacecraft is forcing its way through the air at supersonic speeds, creating intense thermal friction against the exterior hull. Inside the cabin, it's a sensory overload of alarms and heat. The crew monitors critical systems, while the structure absorbs the energy of ascent. This graph shows the acceleration curve. When the heavy side boosters are shed, the reduction in dead weight causes an immediate, aggressive spike in velocity. The vessel continues to roar and shake violently until it finally breaches the upper limits of the atmosphere. The human body was never meant to withstand these conditions. Simply surviving this ascent is as much of an engineering miracle as the rocket itself. Main engine cut off. The roar vanishes, replaced by the sudden, jarring silence of weightlessness. They have now entered the deep vacuum of space, a freezing, highly irradiated environment that is entirely hostile to all known forms of life. Looking back, the violent power of the launch falls away. Against the dead black of the void, Earth appears as a fragile, vibrant blue sphere. Below them, the lunar surface is a gray, lifeless wasteland. It is a stark reminder of the harsh reality of the deep space they've worked so hard to reach. We build these massive machines to prove we can cross the threshold of the void, but gazing into that vast emptiness forces a profound realization upon us. Earth is the only oasis we have. In the face of this vast, dead universe, the ultimate goal of exploration is recognizing we must choose to protect our home and each other.